Hello, geometry students. Today's learning target is to talk about the special properties of rectangles. And a rectangle is a parallelogram, so it means it gets all the properties of a parallelogram, which I'm highlighting in yellow. What makes a rectangle special is not only are the opposite sides parallel, which I am marking, and the opposite sides are congruent, which I marked in blue, but the angles are 90 degrees. So one property of a rectangle is we have 4 right angles. The second property, in addition to the diagonals bisecting each other, so I'm putting the green and the red marks, I'm going to use this computer applet to show you. Here we see all the angles are right angles. If I show the diagonals, you can see that the diagonals not only bisect each other, but all 4 pieces are equal. Even if I make the rectangle a different size, you can see that all 4 pieces of the diagonal are congruent. So it turns out that I don't need different tick marks. I could use the same tick mark for the diagonals. So all 4 pieces are equal, which means the diagonals are congruent. So these are additional properties of a rectangle. Let's take a look at example number 1. Since this is a rectangle, we know all of these angles are 90 degrees. So all of these angles are 90 degrees, which means angle P is 90 degrees. Therefore, 23x plus 44 must be equal to 90. To solve this equation, we'll subtract 44 from both sides. We'll get 23x is equal to 46. We'll divide by 23. So x is equal to 2. Let's take a look at example 2. In example 2, we know that the diagonal NQ is 82. So this whole diagonal I just highlighted in pink is 82, which makes the other diagonal, since the diagonals are congruent, also 82. So PM is also 82. The second property of a diagonal, since it's a parallelogram, is the diagonals bisect each other. So if the whole pink diagonal is 2, to find the length of just half of it, which I'm going to highlight here in blue, I would take half of 82. So 82 divided by 2 is 41. So that little blue piece is 41, and in fact all the little pieces in the rectangle or portions of the diagonal are 41. So that means RQ is 41. It also means PR is 41. And just a side note, notice that this is an isosceles triangle. On the other side we have a congruent isosceles triangle that I highlighted in yellow. And in fact, these pink triangles are also isosceles. Let's take a look at example number 3. If this segment is 40, just like in the previous problem, all the portions of the diagonal are 40. So then PM would be 40 plus 40, which is 80. And then it's not degrees, it's just 80. And then RQ is also 40. So now let's take a look at example number 4. As I explained in the previous example, these triangles, and I'm going to re-highlight them in yellow and pink, are isosceles. And the reason is the diagonals are congruent, so all 4 of these pieces are the same. So what that means, if we have a 25-degree angle for angle QPZ, I'm going to erase that highlighted, that means this angle over here, and I'm going to highlight that in blue, is also 25 degrees. We know QPN is a right angle, so x will be 90 minus 25, and using my calculator, you will get 65 degrees. Because that yellow triangle is isosceles, y is also 65 degrees, and I'm going to mark both of these in my picture. So x is 65. And then we know a triangle, the angles in a triangle add up to 180. So to find z, I'll add 65 plus 65. That's equal to 130. And then to find angle z, I could do 180 minus 130, which is 50 degrees. So angle z is 50 degrees. If I put, say, w here, I do know that we have a straight line. So if I wanted to find w, I could say w is equal to 180 minus 50, which is equal to 130.